Read this question once. Take a moment and see if you can figure out how to solve it. Now, let me show you the same question in a pictorial form. Did the question look complicated? Did the diagram make it feel easier? That's exactly what we'll do in this video. In the next 3 minutes, you'll see how a seemingly complicated IIT JEE Main 2025 question can be transformed into a simple, series, and parallel resistance problem. Welcome to the 11th video of Current Electricity Numerical series. The first concept we need in this question is very simple. For a wire made of the same material and having the same cross-sectional area, resistance is directly proportional to its length. The formula for resistance is shown on the screen. Since the material is the same, the resistivity ρ remains constant. And since the thickness of the wire is unchanged, the cross-sectional area A also remains constant. Therefore, resistance depends only on the length of the wire. So, if a wire of length L has a resistance R, then a wire of length L by 2 will have a resistance R by 2. Similarly, a wire of length L by 3 will have a resistance R by 3, and a wire of length L by 4 will have a resistance R by 4. In short, for the same material and thickness, if the length becomes 1/3, the resistance becomes 1/3. If the length becomes 1/4, the resistance becomes 1/4. Now let's apply this idea to our question. Consider two identical wires, each having a total resistance R. In the first case, we divide the wire into 3 equal parts. Since the length is divided equally, the resistance of each part becomes R by 3. Now, we bend these 3 equal parts to form an equilateral triangle, as shown on the screen. Therefore, each side of the triangle has a resistance of R by 3. In the second case, we divide the wire into 4 equal parts. So the resistance of each part becomes R by 4. We then bend these 4 equal parts to form a square. Therefore, each side of the square has a resistance of R by 4. Let's analyze the square first. Since the wire was divided into 4 equal parts, each side of the square has a resistance of R by 4. Instead of drawing the wire, we can represent each side using a resistor of resistance R by 4. Now we need to find the resistance between the 2 highlighted corner points. To make things easier, let's redraw the circuit without changing any connections. These 3 resistors are connected in series. So their equivalent resistance is simply R by 4 plus R by 4 plus R by 4. Which gives 3R by 4. The other path contains just a single resistor of resistance R by 4. Therefore, between the 2 terminals, we have a resistance of 3R by 4, connected in parallel with a resistance of R by 4. Using the parallel combination formula, as shown on screen, we get the equivalent resistance as 3R by 16. Let us denote this resistance by Y. Pause the video if needed to understand the calculation. Now let's analyze the triangle. Since the wire was divided into 3 equal parts, each side of the triangle has a resistance of R by 3. So we can replace each side with a resistor of resistance R by 3, as shown. Our goal is to find the equivalent resistance between the 2 highlighted vertices. To make the circuit easier to understand, let's redraw it without changing any connections. Now the series and parallel combinations become much more obvious. These 2 resistors are connected in series. So their equivalent resistance is R by 3 plus R by 3, which is 2R by 3. This branch is connected in parallel with the 3rd resistor of resistance R by 3. Using the parallel combination formula, we can calculate the equivalent resistance between the 2 terminals. The result comes out to be 2R by 9. Let us denote this resistance by X. We're almost done. At the beginning of the problem, we defined the equivalent resistance of the triangle as X and the equivalent resistance of the square as Y. We found that X is equal to 2R by 9 and Y is equal to 3R by 16. The question asks us to find the ratio x by y. Substituting the values, we get x by y equals 2r by 9 divided by 3r by 16. On simplifying, the resistance R cancels out, and we obtain x by y equals 32 by 27. Pause the video here if you'd like to verify the calculation yourself. Therefore, the required ratio of the resistances is 32 by 27. And that is our final answer. Notice that the most difficult part of this problem was not the calculation. It was visualizing the circuit correctly. Once we converted the bent wires into equivalent resistor networks, the entire question reduced to simple series and parallel combinations. Thank you for watching till the end. In the next video, we'll solve another interesting numerical from JEE Mains as shown here. If you found this video helpful, make sure to like the video, share it with your friends, and subscribe to the channel for more current electricity numericals. And do comment below if there's a particular problem you want me to solve next. See you in the next video.